Welcome to this video on graphical tools and advanced summary measures in descriptive statistics. In this session, we will dive into techniques that help us understand the deeper stories behind data, not just the averages and percentages, but patterns, relationships, and unusual behaviors. We will begin by discussing why visualizing data is a crucial first step in any analysis. While raw numbers are powerful, they can often hide patterns, trends, or outliers. That is where charts, plots, and diagrams come in. They reveal what numbers alone cannot, whether it is spotting skewness in a box plot or identifying a cluster in a scatter plot. Visualization turns data into insight. After that, we will explore summary statistics that go beyond the mean and median. We will look into terms such as skewness and kurtosis. They may sound technical, but they offer meaningful clues about the shape and behavior of a dataset. These measures help assess asymmetry, tail behavior, and sharpness of peaks, which are important in areas like quality control, finance, and standardized testing. You will also get an introduction to stem and leaf plots, time plots for sequential data, and scatter plots for relationship analysis. Each of these tools provide a different window into the data's behavior. By the end of this video, you will be equipped with a powerful set of tools and concepts to dig deeper into any dataset. So let us get started and uncover the stories that the data wants to tell. First, let us look at box plots, which are also popularly known as the 5-number summary. Why? Because they give you a summary of 5 important numbers related to any dataset: the minimum, the first quartile, the median, third quartile, and the maximum number. Box plots are a powerful way to understand the distribution of data. As you can see on the screen, the central box captures the interquartile range, or the difference between the third and the first quartile. And it also represents the middle 50% of the data, because as we know, the first quartile represents the first 25% of the data, the median represents the 50% point of the data, and the third quartile or the upper quartile represents the 75% point of the data. A line inside the box indicates the median, which is shown here in green. The whiskers, which you can see on the left and the right hand side, extend to values within 1.5 times the interquartile range, or IQR, from Q1 and Q3. As we discussed in our outlier video, any data point beyond that range represents outliers, and these are marked with dots or stars. This structure makes box plots very useful for detecting skewness, identifying outliers, and comparing multiple distributions side by side. These comparisons can be student scores across different subjects or sales performance across branches. For instance, if the median is closer to the bottom of the box, or if one whisker is noticeably longer, your data might be skewed. In this case, you can see that the median is towards the right of the box, or towards the upper quartile of the box, while the lower whisker is longer than the upper whisker. This can guide how you choose statistical tests or whether data transformation is necessary. We will look at further examples of box plots and practice interpreting their features. Whether you are comparing groups or assessing variability, box plots are your go-to visual summary. How do we construct box plots? Let us take a small data set where we have the salary of 10 individuals along with their ID. So you can see the box plot that was constructed using the salary, where the median, which is now shown as a black line, is towards the bottom of the box, which means this is a highly skewed distribution, which often occurs in case of salary. Now, suppose we add another variable, which is gender, which you can see here is coded as 1. So we can construct side by side box plots of male and female individuals, where you can see that the interquartile range, which is the length of the box, is much longer for males than for females. This means that there is a much higher variability of salary in case of males than it is in case of females in this dataset. On the screen, you can also see examples of symmetric and asymmetric or skewed distributions along with their box plots. Notice that in case of a symmetric distribution, the IQ or box is almost in the middle of the diagram because it corresponds to the symmetric distribution or the bell-shaped distribution that you can see above. On the other hand, in case of a skewed distribution, the IQR box is much more towards the left because it is a left skewed distribution. Next, let us look at scatter plots, which are often used to determine correlation between two variables, x and y, or other pairs of variables. Scatter plots are fundamental tools when we want to explore relationships between two quantitative variables, whether the relationship is linear or non-linear. As you can see on the screen, each point on a scatter plot represents one observation in the dataset with values on the x-axis and y-axis. Why are these scatter plots so important? Because they visually indicate correlation or how two variables move together. For example, does the number of hours studied correlate with exam score? A scatter plot will show if more hours typically mean higher scores or if there is no real connection. You will often see different patterns. For example, a strong upward slope suggests positive correlation, a downward slope suggests negative correlation. No clear pattern implies no correlation. But scatter plots also help spot nonlinear trends, clusters, or even outliers. That means points that do not follow the general trend. Another use of scatter plots is to identify heteroscedasticity. That means when variables increase or decrease across values, which is important in regression analysis. We will walk through samples data sets later to understand what different patterns look like and what they tell us. Let us now look at a few different types of scatter plots or scatter diagrams. First, you can see a diagram where there is a perfect positive correlation between the x and y variables. That means the dots each lie on the same straight line. And you can also see a perfect negative correlation which has a rightward slope. That means as x increases, y decreases. However, in real life, in most of the cases, we do not have any perfect correlation. So the scatter plot looks like this, whether it is a positive and linear correlation or a negative and linear correlation. We also discussed that a correlation can be nonlinear. In this case, you can see a negative nonlinear correlation. And in this case, you can see a cluster where there is no relationship between the variables at all. Scatter plots can also be used to find out outliers in the joint variability of two variables. For example, here you can see two variables, hours studied and score on exam. You can see that there is a general linear positive correlation between these two variables. so that as the number of hours studied increase, the score on exam also increases. However, you can see that in one case, one student studied very few hours but even then scored highly. So this is an outlier. So in this video, you have learnt about the uses of box plots and scatter plots. In the next video, I will tell you about stem and leaf plots and time series plots which show data trends over time.